Hello everyone, this video is continuation to nucleophilic addition reaction example. So this is topic nucleophilic addition reaction. In nucleophilic addition reaction in alkynes and carbonyl compounds. Nucleophilic addition reaction in alkynes and carbonyl compounds. So in alkynes completed, in carbonyl compounds one example already given, that is what reaction with HCN. Okay, what is second reaction with some examples? So this is important, nucleophilic addition reaction in carbonyl compounds important. That is nucleophilic addition of hydrogen cyanide and sodium bisulfate, NaHSO3, sodium bisulfite, and next addition of alcohol and addition of sodium acetylide, next Grignard reagent, addition of Grignard reagent, next addition of water or glycol 1,2 dialcohols, next addition of water, and next addition of ammonia derivatives, NH3 derivatives. All these are examples of nucleophilic addition reaction of carbonyl compounds, in which one is completed, hydrogen cyanide. So when carbonyl compound went to the carbonyl compound, so carbonyl compound is maybe aldehyde or ketone. If these two are alkyl groups, that is ketone. These two are alkyl groups, that is what? Ketone. If one is occupied by hydrogen, that is aldehyde. If two occupied, that is also aldehyde, formaldehyde, simple formaldehyde. If one alkyl group comes here, that is aldehyde. Formaldehyde, and see here, this is formaldehyde and this is other aldehyde other than formaldehyde. Both are aldehydes only. If two are alkyl groups, that is what? Ketone. So these two are aldehydes. This is formaldehyde, this is other aldehyde, this is what? Ketone. All these compounds undergo nucleophilic addition reaction. So when carbonyl compound is react with carbonyl compound, means not particularly aldehyde or ketone, that may be anything. So when carbonyl compound is treated with hydrogen cyanide, here cyanide is minus nucleophile. That nucleophilic attack takes place on carbon and this electrophile added here. In the first step, what is added? In the first step, so bond polarization takes place like this, and what happens? This double bond becomes single bond and oxygen become minus by shift of pi electron. This carbon become positive. On positive carbon, cyanide is added. This is step 1. This is what? Step 1, and slow step. And what is the next step? Addition of H plus. Addition of H plus is, this is H plus. Addition takes place in step 2. So this is added here. Then it gives here cyanide and here OH. On the same carbon, OH group and cyanide group both are present. That is called as cyanohydrin. Formation of cyanohydrin. This is what? Nucleophilic addition reaction. So this reaction takes place in 2 steps. In step 1, what is step 1? This is step 1. Step 1 is a slow step because this is not ionic reaction, but this is what? Ion, minus plus. So ionic reactions are fast step. So in general, slow steps are called rate determination steps. In rate determination step, nucleophile is involved. In rate determining step, nucleophile involved. That's why this is what? Nucleophilic addition reaction. So this has been completed in last video. Next, in this video, I am going to explain addition of sodium hydrogen sulfide and addition of alcohol and sodium acetylide, Grignard reagent, glycols, water, and ammonia derivatives. First take this one. Next, first addition reaction completed. Next is addition of sodium hydrogen sulfite. Okay, so its structure is from sulfuric acid like this. Here what is nucleophile in this? Nucleophile is like this. This is H plus, this is minus. You have to take like this. Okay, so what is this is plus, this is minus. Okay, if carbonyl compound treated with when carbonyl compound treated with, this is carbonyl compound, when treated with this reagent, so I will write normally, this is structure, but formula is Na sodium sulfite, this is not sulfate, NaH, okay, sodium hydrogen sulfate. Like this, sodium hydrogen sulfate. Okay, right here NaHSO3. So this is nucleophile. That is important. This is what? Nucleophile. This is nucleophile. So I will write normally NaHSO3. Okay, sodium hydrogen sulfate. So here what? This pi bond shift towards this oxygen, then this become electron rich, and this carbon become electron deficient. Now here SO3Na nucleophile added to carbon and H plus added to oxygen. SO3Na is nucleophile that is added to this positive center, because this is negative in nature, added to positive center. H plus is positive, added to negative center. That's why in step 1 what is added? In first step this one is added, in step 2 this one is added, in rate determination step this one is added. So this is nucleophilic addition. After addition of this one, in first step this is also added. Okay, thus you have to remember nucleophilic addition reaction. Okay, so here first step 1, I do not write step 1, step 2, I will write both steps at a time. Here to the O minus what is added? H plus is added. To the C plus what is added? SO3Na is added. SO3Na. This compound is white crystalline substance. White crystalline substance. The formation of this white crystalline substance, due to formation of this white crystalline substance, this reaction used as a test to distinguish carbonyl compound from other compound. Only carbonyl compounds give this test. Only carbonyl compound form this white crystalline substance. That's why this reaction used as a test to distinguish carbonyl compounds from other substances. This reaction used as a test to distinguish carbonyl compounds from other compounds, because what do you say? only carbonyl compounds give white crystalline product. So if you have a compound physically, formula will not be written on that. If you take a compound physically, add sodium bisulfite, if it give white crystalline substance, the substance, if something is provided to you in a test tube, okay, by looking at test tube you cannot say that is aldehyde or ketone, you cannot say that is carbonyl compound. Then what is test? Sodium hydrogen sulfate is added. If it form white crystalline substance, so then you can confirm that this is what carbonyl compound. That this reaction used as a test for identification of distinguish or identification of carbonyl compound, or for to distinguish carbonyl compound from other organic compound. Okay, so this is which reaction? Nucleophilic addition reaction, because so this nucleophile added in first step to the carbon, H plus added to O minus in second step, but first step is slow step, rate determination step. In that rate determination step, what is added? Nucleophile added. So this is what? Nucleophilic addition reaction. Okay, hope you understood. Take this one. Next, addition of alcohol. Third example, addition of alcohol. Addition of alcohol to carbonyl compound. Okay, so when carbonyl compound, I am taking aldehyde. If you take aldehyde, this is aldehyde. When treated with alcohol, this is alcohol. Okay, so to identify, to distinguish these two alkyl group, so this is from alcohol, this is from carbonyl compound, I labeled one, this is R prime. R prime is also alkyl group, both are alkyl groups only. So to identify this is alkyl group, where is added here, where it will add, to identify that only I labeled here. This is what? Alcohol. This reaction takes place in presence of dry HCl. Okay, right, here what happens? What is formed here? R, C, here what? H, this become O, this become OR prime. So here in step 1 what happens? In step 1, right, in step 1, here this is what? This is nucleophile, this is electrophilic in nature. Okay, so of course it is added in another manner, so like this. So this bond, this is aldehyde, ROH. So here this is what? Nucleophile. This bond shifted like this, and this nucleophile added here. So this gives what? R and C, H, and here this become O minus by taking electron O minus, and this is what? ROH. So due to presence of 3 bonds, oxygen become positive. Now it takes electron, pi electron, then it become RCH, and this is O minus. By taking this bond pair, H plus is left here, this become OR prime. Okay, H plus is lost here. Next, addition of H plus to this carbon, then this product will formed. What is formed here? This become H. See this one, same or not? Same. So this is mechanism. First nucleophile added to this carbon. After that H plus loss takes place, and H plus added to this one. But I will not write all this. You have to understand. Every time it is not possible to write like this. So that is why I am taking charges like method. First O minus RO minus added to this carbon. Step 1 H plus added to oxygen in step 2. Redetermination step is step 1, slow step. So the OR added here, first step, redetermination step, and OR is what? Nucleophile, and this is what? Electrophile. So nucleophile added in step 1, that's why it is nucleophilic addition reaction. So on the same carbon, OH OR groups are present, that's why this is what? Unstable. Okay, this is unstable. So, and if primary carbon, on the primary carbon OH OR groups both are present, on the primary carbon OH OR groups both are present, this is called as hemiacetal. Remember its name, hemiacetal. That is unstable. Okay, so it is unstable, that's why you can write this is reversible reaction. This is what? Reversible reaction. To this, if you add one more alcohol molecule in presence of dry HCl, that is also reversible reaction. Here what happened? First this elimination takes place. See here, ROH, here this is H and this is OR prime. First H plus addition takes place here, then this oxygen become R prime, and this oxygen become, already H is there, one more H is added here, so that become plus. So due to formation of oxygen become positive, it takes away electron, then nucleophile ROH added to this carbon. Okay, so this elimination takes place. So after elimination of this one, I am showing here, this is eliminated like this. Now what is added? One more ROH added. After addition of ROH, what happens? After addition of ROH, I am taking here ROH. Okay, here this oxygen become positive, that's why this oxygen takes bond pair and H plus loss takes place, loss of H plus takes place like this. Okay, reaction takes place like this. So here this is what? This is nucleophilic addition reaction, nucleophile initiated, this is continuation reaction. Okay, step 1 is nucleophilic addition reaction. In all examples, step 1 is nucleophilic addition reaction. So I am taking extra information. One more alcohol in presence of dry HCl, what happens? This is R and here H. This OR become again, OH become OR. This is already OR prime. On primary carbon, 2 alkoxy groups are present, that is what? Acetal. On primary carbon, OH OR groups are present, alkoxy and hydroxy groups are present, that is hemiacetal. And on primary carbon, 2 alkoxy groups are present, that is what? Acetal. Okay, so on primary carbon, remember that on primary carbon OR OH hemiacetal, on primary carbon 2 alkoxy groups, that is acetal. 2 groups acetal, only one hemi means half acetal, complete acetal, half acetal, complete acetal, remember. So if you take ketone, this is aldehyde, ketone means what? Ketone means here, this is ketone. This is ketone or not? Yes, this is aldehyde, this is ketone. Ketone addition of alcohol in presence of what you can write? Dry HCl. What happens here? Same here, this until here, up to here, this is minus, this is plus, nucleophile added in step 1, this electrophile added in step 2. Okay, both I will write in only one step. Then what you get? This is R as it is, R. Okay, same, this O become O minus, to O minus what is added? H is added. Carbon become positive, to carbon what is added? OR is added, OR. Okay. On secondary carbon, OH group, OR group present. Of course, this is unstable. This is what? Hemiketal. 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 On primary carbon, OH, OR present, hemiacetal. On secondary carbon, OR, OH present, hemiketal. So this is continuation reaction, addition of one more alcohol in presence of dry HCl. So what? This OH elimination takes place, OR is added. So what you get? The OH also become OR prime. This is already OR prime. Okay, two alkoxy groups are present on secondary carbon, that is ketal. Identification of hemiacetal, acetal, hemiketal, ketal, okay, is important. On primary carbon, OH, OR present, hemiacetal. On primary carbon, two ORs are present, two alkoxy groups are present, acetal. On secondary carbon, OR, OH are present, hemiketal. On secondary carbon, two OR groups are present, ketal. Okay. So thus addition of carbonyl compounds, addition of alcohols to carbonyl compound in presence of dry HCl gives hemiacetals, continuation reaction acetal, ketone gives hemiketal, continuation reaction give ketal. Take this one. Next, I am taking fourth example, that is addition of Grignard reagent. Addition of Grignard reagent. Grignard reagent. Addition of Grignard reagent. What is Grignard reagent? Alkyl magnesium halide is called Grignard reagent. Alkyl magnesium halide. Alkyl magnesium halide. Alkyl group R, magnesium Mg, halide mean X. This is Grignard reagent. Grignard reagent is organometallic compound. What are organometallic compound? There is a direct bond between carbon and metal. So here what is R? R may be any alkyl group, methyl or ethyl, like this. Okay. So there is direct bond between carbon and magnesium. There is direct bond between ethyl, carbon and magnesium. There is direct bond between carbon and metal. Covalent bond between carbon and metal. Carbon metal. Such compounds are called organometallic compound. Organometallic compound. Shortly OMC. OMCs. So Grignard reagent is organometallic compound. What is specialty in Grignard reagent? So RMGX, in RMGX, both types of bonds are present. Here this is covalent bond, this is ionic bond, X minus Mg plus, and here this bond is not ionic like MgX. MgX bond is 100% ionic. RMGX bond, R partial negative, Mg partial positive, because what? This is covalent bond. In covalent bond, partial positive, partial negative charges are present. Polar covalent bond. This is ionic bond. This is what? Ionic bond. This is polar covalent bond. Poles are there. Positive, negative, partial positive, partial negative. So that is specialty of Grignard reagent. Grignard reagent is what? Alkyl magnesium halide. Alkyl group may be anything. Halide group may be chlorine, bromine, like this, iodine. So this is organometallic compound in which what is nucleophile? R minus is the nucleophile. In Grignard reagent, what is nucleophile? Remember, this is important. This is what? Nucleophile. And the rest will become only this covalent bond will break. Organic means covalent, not ionic. So this is what? Electrophilic in nature. Nucleophile added in step 1. rate determination step, nucleophilic addition reaction. Of course, this reaction also followed by addition of electrophile also, but in rate determination step, nucleophile will add. That's why that is what nucleophilic addition reaction. Okay, so take this one. Grignard reagent, alkyl magnesium halide, organometallic compound. Right? So addition of Grignard reagent to first formaldehyde. Addition of Grignard reagent to formaldehyde. This is formaldehyde. Formaldehyde. RMGX. In RMGX, what is positive, what is negative? Okay, what is positive, what is negative? This is partial negative, Mg is partial positive. Okay, thus here oxygen is partial negative and carbon is partial positive. So this R minus 2 positive, MgX plus 2 negative. Add like that. Then what you get? I will write with blue. This is partial positive, oxygen partial negative, alkyl group partial negative, magnesium partial positive. Okay, right. This gives H here and H here. So to oxygen what is added? OMgX, and to carbon what is added? R. To Mg what is added? R. Okay. Next, this reaction, this is nucleophilic addition reaction. This is what? Nucleophilic addition reaction. Continuation is just hydrolysis reaction. This is what? Nucleophilic addition reaction. Up to here only nucleophilic addition reaction. Up to here nucleophilic addition reaction. And continuation is what? Hydrolysis reaction. Continuation is hydrolysis reaction. In hydrolysis, what you expect? H plus OH minus. H plus OH minus. In MgX, what is plus, what is minus? O minus MgX plus. In water, H plus OH minus. In water, H plus OH minus. Now add positive to negative, negative to positive. What you get? We get H here, C, H. To O minus what is added? H is added. Here R. This is what? Primary alcohol. So hydroxy group containing carbon, this one. Hydroxy group containing carbon directly attached with only one carbon. That is what? Primary alcohol. Primary alcohol, 1 degree alcohol or primary alcohol. Okay. So if you take other than formaldehyde, other aldehydes. Formaldehyde is also aldehyde. Other aldehydes. If you take other aldehyde, RMGX. RMGX. So what do you write? So here carbon positive, partial positive, oxygen partial negative, alkyl group partial negative, magnesium partial positive. Then what will it give? R, C, here H. Okay. To O minus what is added? MgX will add, and to carbon plus R minus is added. So until this is nucleophilic addition reaction. So hydrolysis followed by hydrolysis. So this is what? This is hydrolysis reaction. Hydrolysis reaction. Of course, our example is what? Nucleophilic addition reaction, this part only, but I am giving additional information such that reaction will complete. Okay. So here H2O, hydrolysis reaction. By the hydrolysis, what it form? R here, H here, and here R here, OH. What is side product? To MgX, what is added? OH is added. To MgX, what is added? Write that one first. OH is added. To MgX, OH is added. Here also, to MgX, what is added? OH is added. This is byproduct. So hydroxy group containing carbon, this one directly attached with two carbons. In alkyl group, what is central atom? Carbon. Hydrogen will not be a central atom. So carbon, carbon. That's why hydroxy group containing carbon directly attached with two carbons. So this is what? Secondary alcohol. Secondary alcohol. Okay. Next, if we take ketone, first what we have taken, just these two are aldehyde, simple aldehyde, formaldehyde, other aldehyde. Now this is what? Ketone. If we take ketone, then addition of Grignard reagent gives the same R minus added to carbon, MgX plus added to O minus. So this is same pattern. O become MgX. O to O, what is added? OMgX. To O, MgX added, it become OMgX. Here R is added. Until here, this is what? Nucleophilic addition reaction. Then followed by hydrolysis. Followed by hydrolysis. R here, this is R, and this is also R, and this become OH. So hydroxy group containing carbon directly attached with 3 carbons. So this is what? Tertiary alcohol. Now conclude this one. How? Formaldehyde when treated with Grignard reagent give primary alcohol. Other aldehydes with Grignard reagent give secondary alcohol. Ketones with Grignard reagent give tertiary alcohol. Remember, this is very important. Okay. Take this one. Next, fifth example. Addition of glycol. Glycol is also alcohol. Addition of glycol. Ethylene glycol, like that. Glycol. 1, 2 diols are called glycols. 1, 2 diols. When ethylene glycol is added to carbonyl compound. So this is carbonyl compound. Carbonyl compound means that may be aldehyde or ketone, carbonyl compound. When ethylene glycol is added, CH2, OH, CH2, OH. So nucleophilic in nature. OH group is nucleophilic in nature. So first one OH added here, that give cyclic acetal formation or cyclic ketol formation. That may be cyclic acetal or cyclic ketol. If you take aldehyde here, cyclic acetal. If you take ketone here, cyclic ketol. I will write separately. I am taking aldehyde. Aldehyde means R here, H here, that will become aldehyde. Aldehyde. This is what? Ethylene glycol. Ethylene glycol. Ethylene glycol in presence of acid. In presence of weak acid. Weak acid reaction will take place. So this is R and this is H. It will become a cyclic acetal formation. Primary carbon, it is looking like two OR groups are present. Cyclic acetal. If you take aldehyde, acetal. If you take ketone, that become ketol, cyclic ketol. So like this. This is R. Formation of ethylene glycol. OH here, OH here, and this is CH2, and this is what? CH2. In presence of weak acid. Weak acid. Okay, right? So same reaction. To remember, I am taking like this. Okay, removal of H2O. Of course, this is not elimination reaction. not removal of H2O, but addition reaction, nucleophilic addition reaction. What is product? What will be product? R here and C here. To write product only this information. Here O, CH2, here O, CH2, between two CH2 there is a bond. This is what? Cyclic ketol. Cyclic ketol. So this is also nucleophilic addition reaction. This reaction takes place like this. Mechanism, if you see mechanism, so this is, if you take ketone, okay, ethylene glycol. In ethylene glycol, OH group is what? Nucleophilic in nature. OH group is what? Nucleophilic in nature. So reaction of aldehydes with alcohol. First step hemiacetal, second step acetal. Ketone with alcohol in presence of dry HCl, hemiketal, ketol. Here two steps at a time. Ethylene glycol, two alcohols added at a time, that gives cyclic acetal. First this one added hemiketal, and this one also added ketol, like that. So first polarization of bond like this. This H added here and this one added here, this to this carbon. This OH eliminated, then this one added here, like this. That is nucleophilic addition reaction only. Nucleophilic addition, but it is looking like elimination, but not elimination. This is nucleophilic addition reaction only. Okay, take this one. Next, addition of ammonia derivatives. Addition, nucleophilic addition of ammonia derivatives. Ammonia derivatives on carbonyl compound, nucleophilic addition reaction. So take this one. Ammonia derivatives. What are ammonia derivatives? NH3. I am writing like this, NH3, ammonia. Instead of hydrogen, if anything come. Anything means if OH group come, it become hydroxylamine. Hydroxylamine. If you take OH group instead of hydrogen, that become hydroxylamine. Or if you take NH2 again, NH2, instead of hydrogen I am taking NH2. This is hydrazine. Its name is hydrazine. Hydrazine. Or instead of hydrogen I am taking NHPH, phenyl. This is what? Phenyl hydrazine. Phenyl hydrazine. Phenyl hydrazine. Okay. Or instead of this H I am taking same but at 2,4 position. At 2 position nitro, at 4 position nitro. This is what? 2,4 dinitro phenyl hydrazine. Important. 2,4 dinitro at second position and fourth position nitro, numbering from here 1, 2, 3, 4. 2,4 dinitro phenyl hydrazine, like this phenyl hydrazine, but what is different? 2,4 dinitro phenyl hydrazine. Phenyl hydrazine. 2,4 dinitro phenyl hydrazine is also called Brady's reagent. Brady's reagent. Brady's reagent. 2,4 dinitro phenyl hydrazine. Or instead of hydrogen, if you take NHC double bond O NH2, that is called semicarbazine. 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 So all these are what? Nucleophiles. How they become nucleophile? Here this nitrogen become nucleophilic center, nitrogen become nucleophilic center. So thus all these are what? Nucleophiles. Addition of these nucleophiles to carbonyl compound. Nucleophiles addition to carbonyl compound I am going to explain. So all these are what? Nucleophiles. All these are what? All these, and this one also nucleophiles. Neutral nucleophiles. Neutral nucleophiles. Now I am going to explain addition of these neutral nucleophiles to carbonyl compound. All these are neutral nucleophiles. I am going to explain addition of these neutral nucleophiles to carbonyl compounds. Okay. First, carbonyl compound, addition of carbonyl compound, addition reaction of carbonyl compound with, first of all I am taking hydrogen. I will explain one, we can apply all. So how this reaction takes place, mechanism I am going to explain. C double bond O here, NH2, this may be anything, for all it is applicable, this may be anything, that if it is NH, this may be OH, this may be NH2, this may be anything I will take, okay. So for all this is Z may be anything, okay. How this reaction takes place, nitrogen is a nucleophile, okay, right, nitrogen nucleophile, this carbon is electrophilic because oxygen more electronegative, taking electron, it is negative, partial negative, and this is what? Carbon is partial positive. Now this added here like this, and it gives what? C, oxygen become O minus completely, and this is NH2, and some Z is present. Due to presence of 4 bonds, this nitrogen, it takes electron, and H plus is eliminated here, that H plus added to here. That forms what? That forms here carbon, this is OH, and this is become NHZ. The reaction takes place. Clear or not? Yes, clear. Now I am writing this NHZ separately, NHZ is added, NHZ, H plus eliminated, and that added here. So until here this is what? Nucleophilic addition reaction. This is what? Nucleophilic addition reaction. Now elimination, I am going to write elimination. How elimination takes place? These two are eliminated. This bond shifted here, it goes away like this. How will you write? I will write like this. Okay, this oxygen takes away electron, and it is eliminated as H plus, this bond shifted here, that becomes C, and between these two carbon already a bond is there, one more bond, NZ. What is eliminated? Water is eliminated, H plus OH minus, OH along with electron minus, H bond pair not shifted, only H plus eliminated, this bond pair shifted to here, thus H2 eliminated. So addition followed by elimination, nucleophilic addition reaction followed by elimination. So here what? This is what? This is elimination reaction. Addition, elimination. Our example is this one. I am giving this extra information, elimination also. Okay, right. This is the mechanism. Take this mechanism. Then for all the reaction, I will not write this mechanism, directly I will write. Okay, direct reactions I will write. This is the mechanism how this reaction, first nucleophile added, then nitrogen become positive, H plus shift takes place here, then from carbon OH group from nitrogen, H plus last takes place. So it become double bond. Thus the product is formed. Here elimination, here nucleophilic addition. That means this nitrogen require 2 hydrogen. This nitrogen require 2 hydrogen. 1 hydrogen to shift here, 1 hydrogen to eliminate here. This nitrogen require 2 hydrogen, 1 hydrogen to shift here, another hydrogen to eliminate here. Then only this product will form. Okay. Right. Take this one. What will be expected product? This one. This one. So here it is looking like elimination of water. Correct. So here this become OH and this become NHZ. Step 1. Then after that elimination of H2O. Then this become NZ. If you see directly, this reaction looking like what? This reaction looking like direct elimination of water. Take this one and put a double bond here, NZ. Same or not? Yes, same. Of course, reaction takes place in this mechanism, nucleophilic addition reaction mechanism, but to write equation, direct product, fast step, fast method. So don't write like this nucleophilic addition followed by elimination. This is late process. Direct remove like this, you can get product. Of course, this is not a direct elimination. This is nucleophilic addition followed by elimination reaction. Okay, nucleophilic addition followed by elimination reaction. Nucleophilic addition followed by elimination. Elimination reaction. Nucleophilic addition followed by elimination reaction. Okay, right. So I will write one by one equation. That is first. In this one ammonia derivative, I am adding first which derivative? Which ammonia derivative? Hydroxylamine. I am writing hydroxylamine. In the place of Z, here OH is present. What is this? Hydroxyl. Because of hydroxy group present, amine, NH2 group is present, so amine, hydroxylamine. So what you can take? Elimination of this one. Directly you can write product. What? Here carbon, double bond, nitrogen, OH. With hydroxylamine, what it gives? Oxime. This is remember. This will remember. Okay, you have to remember this one. So carbonyl compound with hydroxylamine form oxime. Carbonyl compound, that may be aldehyde or ketone, with hydroxylamine form oxime. That may be, if it is aldehyde, aldoxime. If it is ketone, ketoxime. I will maintain that clarity. Okay, if it is aldehyde, what you get? Aldoxime. If it is ketone means only one difference. Here 2 are alkyl groups, then that is ketone. Hydroxylamine, it give, here this is what? R, and this is what? H. Here this is R only, this is R only. Okay. If you take aldehyde, RH. If you take ketone, RR. This is aldoxime. It is if you take a ketone, what you get? Ketoxime. For aldehyde, aldoxime, for ketone, ketoxime. So this is one example. So take this one, take this one. Next, addition of hydrogen, addition of hydroxylamine completed, addition of hydrogen. All reactions are similar. All these reactions are similar. Addition of hydrogen. Addition of hydrogen to carbonyl compound give hydrogens. So this is one carbonyl compound. I am adding hydrogen. What is its name? Hydrogen. Hydrogen. Right. What it will gives? Remove H2O here. NH2. This is hydrogen. Hydrogens give hydrogens. Hydrogens give hydrogen. This is also nucleophilic addition reaction followed by elimination of water. Nucleophilic addition followed by elimination of water. Next, if you take phenyl hydrogen, carbonyl compound, I am taking not simple hydrogen. Simple hydrogen is NH2. Instead of one hydrogen, if phenyl group is present, that is phenyl hydrogen. Phenyl hydrogen. Phenyl hydrogen. Then it gives what? Yes, same. C here N, single bond NH, PH. PH means phenyl group. This is phenyl group. This is phenyl hydrogen. Phenyl hydrogen give phenyl hydrogen. Phenyl hydrogen. Nucleophilic addition followed by elimination reaction only. Next, if you take 2,dinitrophenyl hydrogen, that is Brady's reagent. 2,4-DNP, shortly 2,4-DNP. 2,4-dinitrophenyl hydrogen. Phenyl hydrogen. 2,4-dinitrophenyl hydrogen is also called as 2,4-DNP reagent. 2,4-DNP. 2,4-DNP is also called as what? Brady's reagent. Brady's reagent. This reaction useful in identification of aldehydes, ketones, carbonyl compound identification, because with 2,4-DNP it form red-orange color crystals. Red-orange color crystals. This is what? 2,4-dinitrophenyl hydrogen. Phenyl hydrogen give phenyl hydrogen. 2,4-dinitrophenyl hydrogen. This 2,4-dinitrophenyl hydrogen is a red-orange color substance. Formation of this red-orange color substance confirms that the given compound is aldehyde. Suppose some unknown compound is given to you and you have to identify whether it is aldehyde or not. Then what we have to do? Just simple add 2,4-DNP reagent. 2,4-DNP reagent. If orange color crystals are formed, the given compound is aldehyde or ketone, carbonyl compound. If orange color crystals are not observed, that is not carbonyl compound. Thus, this reaction used as a test. Okay, right. Take this one. Similar reaction, instead of Z, I am taking NHCONH2. That is semi-carbazine. That forms semi-carbazone. Very simple. If you take semi-carbazine, that forms semi-carbazone. right, carbonyl compound, if addition of NH2 here, instead of Z I am taking NHC double bond O NH2. Its name is semicarbazine. So simple, remove H2O, then write semicarbazone. Semicarbazenes give semicarbazones. Semicarbazenes give semicarbazone. That's it. So these are the reaction, addition of ammonia derivative. And next one is addition of sodium acetylide. Seventh one, last one, addition of sodium acetylide. Addition of sodium acetylide. So see this to the carbonyl compound. This is carbonyl compound. I am adding sodium acetylide instead of hydrogen acetylene. CH triple bond CH acetylene. If sodium comes, that is called sodium acetylide. Okay. Now here this is H, this is minus, like this reaction takes place. So don't, for explanation, okay, this is plus, this is minus. Add minus to this positive carbon and H plus to this negative oxygen, you will get product. What? Here same, 2O minus H is added. Here what? C triple bond CNA. So here Na is removed by the addition of acid, then it gives what? COH here, and this becomes C triple bond CH. This sodium replaced by H plus ion of water, H plus ion of acid, so it becomes acetylenic acid. Remember one thing, in all these reactions, first step is what? In all these reactions, first step is nucleophilic addition reaction. Don't take a second step. If you see the second step, that may or may not be nucleophilic addition, just to focus on, in all examples I have given, you have to focus on step 1, that is nucleophilic addition reaction. Okay, next I would like to give one example, that is important example.